So we know that the equivalent resistance of the combination of resistors, of all the resistors combined, is equal to 28 ohms. So we just need to use a combination of the parallel and series resistance formulas to get us to find what R is. So I'm going to use a technique my teacher taught me. We kind of just call it color coding. It's very useful for resistors that are in parallel, to tell if resistors are in parallel. So if you want to know if resistors are parallel, you simply color code. You start wherever a battery is. I'll assume there's a battery here, but there technically isn't. And you keep coloring with one single color until you hit a resistor, something that stops you from going further down. You can't do that. The moment you hit a resistor or any other component in a circuit, you change colors. So now I can't use pink anymore, I'll have to use blue. Until I hit another resistor or another component in the circuit where I can't use the color anymore. So I'll use blue here as well, and there's blue here as well. So now, what this tells me is that all three of these resistors are in parallel. Why? Because R here, the R here, and the R here are all the same. And this R is also the same. The value of the resistance of each of these resistors is the same. The voltage at every single, maybe I'll use a different color. The voltage at every single point on the pink lines is the same. So if it's 10 volts at this point, it's also 10 volts at that point. Or it's also 10 volts at that point, that red dot right there. But when you move through a resistor, the voltage will drop always. Whenever you move through a resistor, there's always a voltage drop. It's a fact. So now the voltage has changed, and I'll assume it drops down to 5 volts. So the voltage is now 5 volts here, 5 volts here, 5 volts here, 5 volts here, 5 volts here. It's the same everywhere on this blue line until we hit this other resistor here. The only idea behind this color coding technique the teacher taught me is that it'll tell you which resistors are in parallel to each other. And now we know that essentially these three resistors are in parallel. So we're going to combine them. I'll draw the circuit first into one resistor, like that. I'll call that R, R, the three R's telling us that we've combined them. And then we of course have our other resistor, or this guy, essentially. That's what we have. So we know that these three are in parallel, so we basically use that inverse resistance rule. And yes, we can do it for three resistors like this. And so what we get is 3 over R when we add the fractions up, inverse. So what does that mean? 3 over R inverse is actually equal to R over 3. So I'm going to erase this now. So the resistance of the three resistors combined is defined as R over 3. Now these two guys are in series, so we just add them up in series, and we get R equivalent to being equivalent to which means we have R over 3 plus 3 over 3R, which is equal to Basically 3 over 3 is equal to 1, so it's just the same as saying 1 over 1r, sorry. 3 over 3 times r is equal to 1 times r. Same thing. Because 3 over 3, 3 divided by 3 is 1. I'm just writing it as 3 over 3 so that it's easier to add those fractions, which give us 4 over 3. So our equivalent resistance is equal to 4 over 3 times r. That's awesome. They gave us our equivalent resistance, so now I'm going to erase a lot of stuff. So our equivalent, we already know that is 28 ohms, which is equal to 4 over 3 times r. So we do r is equal to 28 ohms divided by 4/3. 28 ohms divided by 4/3, and that gives us 21 ohms. And what do you know, that is the correct answer. I hope this helped, and have a good day.